Yeah.
All right. Real life quadratics. I love the title. I love it. All right. So quadratics are all around us. And you're going to see some real life examples of that. As soon as this Jamboard loads. All right.
Okay.
All right, it says a golfer hits a ball off the ground. Its trajectory is modeled by this equation. I'm going to have to write that down because I can't see it very well. Can you tell me what it is? Does it say h of x?
It says f of x equals -16 parentheses x minus 4 parentheses
Square. Okay.
Yeah. Plus 256.
All right. So how high will the ball get? Well, that would be the vertex. How high will it get will be the vertex. And notice that we have this in vertex form.
Yeah.
Do you see that? Mm-hmm. So your vertex is 4, 256. And the reason I know that's going to be the top point is because this is a negative A, which means the parabola opens up down.
Okay.
You remember that?
Yeah.
So my vertex for this is going to be 4, 256. So how high is it going to get? Which one of those is the height?
I think it's 4.
Nope, this is the time.
Okay.
Because if you look at it, it said X is time. It probably said that. I don't see that in here, but it probably said that. So this is the time.
256.
This is probably, yeah, this is the height.
Okay.
I can't read it exactly, but I'm pretty sure that your equation, did it tell you what X and f of X are?
No.
Did it tell you what they represent?
No.
All right. Well, yeah, it's going to be 4. I'm sorry, it's going to be 256. And 4 is probably like the time in seconds. So it probably goes as high as 256 feet in the air, which seems a little high. I mean, it could, I guess if it's a wedge, it possibly could be that high. If it's like Bryson DeChambeau, whatever. It's surprising that it didn't tell you what the X and Y represent.
Yeah.
Because it seems like it should tell you that. When is the ball at its highest point? So this is the when. The X is the when, and this is the how high.
Okay.
Are you sure it didn't tell you what X and Y were, or X and F of X?
Yeah.
All right, you're sure?
Yeah.
Yeah. Then it's a word problem that is lacking a little bit of. It's lacking a couple words. It should tell you that. But we can figure it out. What's the next question say? What's the next part of it say?
B says sketch a graph, and then C says how long before the ball hits the ground.
All right. So sketching a graph would just be, we're going to plot it. And you know what? Let's do C first, or D first. Let's do. Are there 2 B's in here?
Yeah.
B and B. Okay. All right. So yeah, this is a pretty ghetto math worksheet problem. It looks like they're missing all kinds of stuff.
Yeah.
But it's okay. How long until it hits the ground? So what we're going to do is it's going to hit the ground when this equals 0, when the height is 0, right? So we're going to solve this equation to find when it hits the ground. So we're going to plug 0 in because that means that it hits the ground, right?
Yeah.
And we're going to solve this equation. So first, subtract 256 from both sides. minus 256 equals negative 16 times x minus 4 squared. Now divide both sides by 16. 256 divided by 16 is 16. That's what I thought. 16 equals x minus 4 squared. Now take the square root of both sides to get rid of that, right? So what's the square root of 16? It's plus or minus 4. It's 4, basically. The square root of 16 is 4. But remember, there's two. There's one's a positive 4 and one's a negative 4. Because remember, there's going to be two places that it hits the ground because it's a parabola.
Yeah.
Right? So one of the places is where it's negative 4. And one of the places is where I plug in positive 4. So this answer equals x equals 0, which makes sense, right? And for this answer, x equals 8.
Okay.
Okay?
Yeah.
So the question said, how long before the ball hits the ground? And the answer is 8 units, seconds or minutes. Obviously, they didn't tell us what the units were here, but I'm assuming it would be seconds. So the answer is 8 seconds with the question mark underneath the word seconds. Okay?
Yeah.
Good with that one? Was that all of them?
Yeah.
All right. Oh, another awesome picture. How high did the soccer ball get? All right, tell me what the equation of this is.
F of x equals negative 16 parentheses x minus 1 squared plus 20.
All right. So same thing, how high will the ball get? Same thing, we've got our vertex form equation. So my vertex tells me how high it will get, and my vertex is going to be 1 comma 20. So this is the height.
Yeah.
I don't know if it's in feet or what, because apparently they didn't tell you. And then this is probably the seconds after it was kicked. Does that seem right?
Yeah.
So this again, how high did the ball get? That would be 20 feet or whatever. And when was it? That would be after 1 whatever second or whatever the units are. And then sketching the graph, of course, to sketch the graph, I first have to find out when it's going to hit the ground. And what do I do to find out when it's going to hit the ground?
Do the parabola.
Yeah, what's the height going to be when it hits the ground?
Oh, 0.
Yeah, so you plug 0 in for f of x, right? That's when it's going to hit the ground.
Okay.
So this equals negative 16 x minus 1 squared plus 20. Subtract 20 from both sides. See what I'm doing? You good with this?
Yeah.
Divide both sides by negative 16, and you're going to get 5/4 x minus 1 squared. Take the square root of both sides. You're going to get the square root of 5/2 equals x plus x minus 1. So solve that. X equals 1 plus or minus the square root of 5/2. Remember, there's 2 points you're going to get, right?
Yeah.
You're going to get 2. It's a parabola up downward like this. So your height was 20 at 1 second. I kind of feel like something maybe isn't right with this. Are you sure that it was Are you sure this was positive 20 and not a negative 20 right here?
Wait, for this, positive is negative and negative is positive, right?
Well, no, just tell
Oh
me what
no,
the
it
equation
says
said.
plus 20.
It says plus 20?
Yeah,
It does?
yeah.
Oh yeah, no, that would have to be, it would have to be a positive 20. I'm just surprised that that number didn't work out like the other one did.
Yeah.
So your height, your vertex is at 1 comma 20. So your vertex is right here. Look at my graph. 120 is your vertex. This is 1, and this is 20 over on the x-axis or the y-axis. And your intercepts are, let's see, that's 2. Yeah, so you're actually, it's going to be here. Yeah, I guess that kind of makes sense. So he's kicking the ball. The ball wasn't on the ground when he kicked it. The ball was up in the air when he kicked it. He wasn't kicking a ball that was laying flat on the ground. The reason I know that is because of this. 1 minus the square root of 5 over 2 is going to be a negative number because this is bigger than 1. So it's going to be over here.
Okay.
So when he kicked the ball was not sitting on the ground. The ball was up here. That makes sense?
Yeah.
So this is how far the total distance that it went is 1 plus the square root of 5 over 2, which is 1 plus, you can use your calculator for this, I think. Well, come on. Clear. 1 plus the square root of 5 divided by 2. 2.12 is where he was. 2.12 seconds is how long it took for the ball to get to the ground.
Okay.
Okay, that makes sense?
Yeah. Wait, it took
So you're
2.12 seconds for the ball to get to the ground?
correct.
Okay.
Do you see? So your picture would look like this. And that point right there is 1 comma 20. And this point is 2.12.
Okay.
Okay.
Yeah.
And see the other point. Do you see what I'm talking about down here? The other point, if you would have followed this down, the parabola down to the other side, it would have landed on the negative area. It would have landed negative.
Okay.
Do you get what I'm saying?
Yeah.
And they actually even showed that picture. With the picture, they're even showing you that he's perhaps kicking the ball when it's up in the air a little bit. Oh man, these are awesome. I love the sports theme.
Yeah.
A batter hits the ball. The path of the ball is modeled by the formula. Tell me what that formula says.
F of x equals negative 16, parentheses, x minus 5, parentheses, squared, plus 576.
All right. Good hit, buddy. Good hit. So your vertex is
5, comma 576.
good. So what's the highest it goes? Or the farthest rather? The farthest it goes?
576.
Is that the highest or the farthest? The path of the ball. No, that's the highest. The path of the ball.
High.
Yeah.
It says how
so
high,
this is,
I think it's how long or how far.
oh, it's probably high. It's probably high.
Oh,
No,
okay.
it's definitely high. This is not distance. This is height. Well, we can find the distance, but the distance is when it lands on the ground again. So the max height is 576, and that's the time it takes, right?
Yeah.
And so they're going to probably ask us how far, or actually not how far. They're going to ask us when it hits the ground. So how do I do that?
You draw the parabola of like where it leaves.
This is f of x equals 0 for when does the ball hit the ground. So I'm going to plug 0. I'm going to plug 0 in for f of x, and I'm going to solve just like I did the other ones. Okay.
Okay.
So subtract 576. Divide 576 by 16. Where is this coming from? Quit. 576 divided by 16. 36. Well, that's nice. Because 36 is a perfect square, right?
Yeah.
So the square root of it is 6 plus or minus 6. So again, you have two answers because one of them is going to be to the right, one is going to be left. So either x equals 6 minus 5 or x equals negative 6 minus 5.
Okay.
Which doesn't make a lot of sense, to be honest with you. Because this is 1 or negative 11. Okay, that does not make any sense. Oh, yeah, because I did it wrong. I forgot to add 5. One of them I'm adding 5 on both of them. Yeah, that makes a lot more sense. I'm like, what's wrong here? This is 11 and this is negative 1. So negative 1 is here. 11 is over here. 5 is right here. The maximum point was at 5, comma 576. It went like this. Does that make sense?
Yeah.
So now the question says, how high was the ball off the ground at 3 seconds? Well, 3 seconds is your x. So plug in 3 to the equation. What's f of 3? Plug in 3. Every time you see an x, you plug in 3 instead. So your equation is going to be, I'll write it in red, but I'll not write the x because that's going to be written in blue because that's how you do this. So your equation, you're plugging 3 in for x. What's 3 minus 5?
2. Or negative 2.
It's negative 2. And what's negative 2 squared?
Negative 4.
Positive 4.
Oh, yeah. Okay.
And 16 times 4 is 64.
Yeah.
So subtract those, not add them. Subtract them. 576 minus 64 is 512.
I think so. Mm-hmm.
So that's your answer for that one. Okay.
Okay.
That it? Or you got another one?
I got one more.
Warm up. What's the Y-intercept? You tell me.
Tell
me how you do this one.
Is it 32?
The Y-intercept is where x equals what? Think about an axis. What's the Y-intercept?
X equals 0?
Yeah, x equals 0. The Y-intercept is where x equals 0. 0 comma what? So what I do is I plug in 0 for x and I solve for y. So y equals 2 times 0 minus 3 squared minus 32. What's 0 minus 3?
-3.
Good. What's that squared?
-9. Or yeah, +9.
You see how you got to do it step by step?
Yeah.
And what's 2 times 9?
18.
And what's 18 minus 32?
14.
-14. Good. -14. Now the next question says find y when x is 5. So what do I do?
You plug in every x value for 5, or you plug 5 in for every x value.
That's right. And I only have one x value, so it goes right here. Hey, didn't we already do this problem? Because this is +2, but does it matter if this is a +2 or a -2? Oh no, sorry, it was 3. My bad. Change that. I thought we just did this on the opposite side. So we're gonna, what's 5 minus 3?
2.
2 squared?
4.
2 times 4?
8.
8 minus 32?
28.
Nope.
Wait, 32. 20. Okay, yeah, 24.
Got it?
Yeah. Okay. 4.
Make sense?
Yeah.
Questions about any of those things that we just did?
No. Wait, so for when it says like plus or minus, like a number, like plus or minus 6, does that mean like there's a +6 and a -6?
Yes, it means that it can be a positive or a negative. So
Okay.
you have to do it twice. You have to do it once with a +6 and once with a -6. Like write 2 different equations.
Okay. All right. Okay.
Good. You got any other ones or is that it?
Oh, that's it.
All right. Well, hey, good luck and I'll see you next week.
All right. Thank you.
See you,
Have a
bud.
good night.
You too.